Hey, we are here again, and today I am going to modify this power supply for 14.2 volts or 13.8 volts. Depends on how much I can get it from it. And last time I created a video but got destroyed, don't know how or why, and so many people told me that okay, the shot I posted was useless. But hey, here I'm again, and you guys can see this is the version of the power supply. Right, it's DPS 1200 FBA, and this is a version 2 power supply, version 2 board of this. So now I am going to take the covers off of this power supply and have a look what it says. Right, so there are a few screws. You need a small screwdriver like this, and it will be easy to open this up with this screwdriver. I'm going to change the bit. So there are 4 screws on the top in total, and after taking those 4 screws off, this power supply cover is going to come off. Now inside this power supply you can see there's a black cover, right, and there's a silicone strip. This silicone strip is used to dissipate the heat from the heat sink, which is underneath this black cover. And this power supply has opened up before. So I'm going to take this cover off gently. I can only try, but hey, I'm going to move it to this side, and yep. So you guys can see, oh, switch it. You can see this old black dust, right? And you can see there's a heat sink, and this silicone strip goes, or silicone pad goes on top of this to dissipate the heat. Now the main modification I need to do is on this side of the power supply. Right, and I will zoom in my camera so it will shake in a little bit. So I hope you guys can see. I will try to keep it in focus. So there are 3 variable resistors here. We are going to use one of these resistors and jump 2 wires across the resistor and this pad here to here somewhere. So I may post a photo after soldering that, okay, how I did it, right? And after doing that, you need to insulate those resistors and put it back properly, and make sure those resistors do not make any short circuit. After that, we can turn on this supply and find out if our modified power supply works. So what I'm going to do, I'm going to hold this cover down and try to find out which pad I need to solder, because I have checked online, and thanks to this guy who made that video possible. Now here are the resistors which I am going to use. I will list these resistor values into the description, or I will attach a document how to fix it and how to do it. Alright, and here are the resistors. So we need 2. One is 22K and 110K. So let's fix the easy one first, and I will try to hold this cover down. And make sure you have good soldering iron with precision tip like this one. This is with very small tip, because you need to have the small soldering iron, because the points are where you're going to solder are very small, and the temperature control is required, right? So do not burn and use lots of flux. So I'm gonna turn on my soldering iron, and we will need so much flux on it. So it would be better if I tape it down at the back, because this is going to annoy me again and again. There you go. Now we'll have a clear. So it will be good if you use this kind of resistor and use this kind of sleeve on top of it to cover it. I think this one is too tight. Change it to the black. Yeah, I hope this will work better. So I can put that sleeve later on. So what I'm gonna do is scrape that point where I am going to solder. So I'm not sure if I can show you guys. That's a very fine point. I'll take a photo of it and post it online. So here I am using flux over here. So I'm just gonna try to point out what I am going to do. Over here, this is a 1 point. Still, the camera is not focusing. Yep, so over here, there's 1 point. And the second point is somewhere here. So I have taken a picture and I will post it in the description and you guys can find out there. So I am just going to do it a bit off the camera. So you guys can see that it does not take much solder. So it's here, right? It is on this pad, and I will try to solder the next one. So I am little bit worried about that the direction of this resistor wire is going to short circuit something. So I'm going to take it off and put it on another side and try to make a better connection, because I don't want it to get short circuit. And I'm going to take it off and try to change the direction of the wire to that side, and let's find out what happens. All right, I have installed this resistor. As you guys can see, I have to scratch a bit more over here so that I can make the connection a bit strong. Now you can see, if you can, on here, that I have put a bit more solder on this spot. And I'm going to solder this side on here. And I'm gonna do it off the camera, so stay with me. All right, here we are, and I have fixed this resistor in here. You guys can see clearly, I hope. And I have checked the connections around for the continuity, so to make sure that it's not shorting anywhere. So that is also an important step. Now the other connection. The other connection is from this resistor, variable resistor, to here. So very short path, and we need to use 22K resistor now. We have used 110K, and we have to use now 22. So here's our 22K resistor. And I will install it now. So what I have done here, it insulated the resistor, you guys can see, right? And I'm going to install this one, and this is 22K. That's too far for me. All right, my connections are successful here, and now I am going to test it, that how much I can get the output from this power supply and what I need to adjust. All right, you can see I have packed it tightly so it doesn't take so much space or bulge the insulation over here, and both of the resistors are protected by the heat shrink sleeve, and I hope this is going to work. And now I am going to find out if this works or not, because hey, anything can happen. So I'm gonna give it a bit cleanup with the alcohol spray over here and on the connections. So let's check and find it out that what happens. So I'm going to plug this power supply. Okay, so that's a bit safety concern now, because we are going to connect 220 volts of power supply. So make sure you follow the safety guidelines, right? Because I have MCBs at home, so circuit breakers, or if something happens, it's going to break. It's going to drop itself down, and I will know that okay, something is faulty or working or not working. So it is working, but I need to check voltage. Fans have started, but I don't know if it is giving output yet or not. So I am not getting any output at the moment, because we need to short a pin on this area, right? And then we will get the full power output. So let's do it that too and find out what happens. So I'm going to disconnect it for a while and see what happens. So make sure you do not touch the surface, because there are capacitors over here and you can get electric shock. But hey, these supplies are designed well, and I hope the capacitors are discharging itself when it shuts off, because this was used in a computer, in a server. So I think there are safety features to avoid short circuit or power surge, because servers are too costly. So if that power supply burns the server, not good. Okay, so I'm gonna zoom in a little bit more, and you will see here I have pin number. I don't know what pin is that, but I can see over here 33, 37, so 33, 34, 35, 36, and 37. So we need to jump pin number 36 and 37. So, and we are going to use 22 K resistor in here as well. So I'm gonna do it quickly and get back to you guys. So I'm gonna do it temporary to see what happens. Then I can put a switch in here to start the power supply. Okay, so it is done. Right, not a very good connection, but it is done. Right now, we are going to test it, that if it is working or not. So here goes our 220 cable. So light is running. And let's see how much it outputs. So here's my multimeter, a clamp meter, right? Let's check it. So there's no output yet. Kind of wondering why. What am I doing wrong? So just a millivolt. Tap. So, need to find out what's going on. Alright, I'm back, and what I have found online and on the information, that I need to jump pin 33 and this big ground to get the output. So now I am going to jump that wire So I'm going to use a little bit solder there. Alright, this wire is joined. Now we can test it. So let's check if it's outputting or not. Well, there you go, 13.5. So you can see the multimeter. I'm gonna move it. Right, and as I'm touching, 13.52. Right, 13.52, and that's very good. Now, what we also can do, adjust those potentiometers. These potentiometers, this one, to find out how much total output we can get. So I'm going to use my little screwdriver here and try to adjust while holding these pins with both one of my hand. So 13.5 I can see. .1, okay, I'm rotating the other side. 13.6, 13.7, 13.8, 14. Okay, so over voltage protection turned on, right? So what I have to do now, restart the power supply. Let's check it. 13.5. 13.6, 13.8, 13.9, and 14. So I think this is gonna go to maximum 14 volts because the resistor we added in here, it jumps the over voltage protection up to 14.2 volts. So whenever it goes near to the 14.42 volts, it shuts off the power supply, so which is a safety function. Now, when this resistor was not there, so I think the over voltage protection was lower, the number was lower, so I think it was cutting up to 12.5 because it has to protect the server or computer, whatever is attached to this. So the point of adding this resistor to raise that over current protection or over voltage protection, sorry, up to 14.2 volts. Right, now we can see in here it is 14.07, so which is fine. I'm happy with that, right, because I will be using it as an automotive power supply, automotive car power supply, because when you do any programming on the German cars like BMWs, Audis, right? So I'm not going to use it on newer cars for sure, but whenever I will do old cars or program old cars, I have to use this power supply because those cars draw so much current from the battery during the programming that battery goes down and you can damage the control unit. But when this power supply is attached, this power supply can provide current up to 80 amps, which is sufficient during the programming. So that's why I made it. So now what I will do, I will put an amp meter and the voltmeter on it to see how much it draws. So that project is for the next video. So yep, so I'm gonna cover it up and fix it back, and let's see what I'm gonna do next, because I have to create 2 terminals to put thick wires in here on the side, and I wish I could have a potentiometer outside so that I could adjust the voltage. So now what I'm gonna do, I'm gonna fix it back and start using it for a while and see how it performs. I hope it will perform better, and then I'm gonna think about next step, what to do with this. Okay, we have our enclosed power supply, which can output now 14 volts. Nothing is inside, and we are done with this. So guys, thank you for watching this video, and please like, share and comment on the video, and subscribe to my channel to support me. Please like, share and subscribe. Thanks for watching guys. Thank you very much.